imprinting. Do you remember what that means? It's when a gene's expression, and therefore the phenotype it produces, depends on which parent it was inherited from. For example, let's say in one person, the allele from one parent is imprinted, which is the black one here, and the other is expressed, which is the orange one. Imprinting can be established by methylation of the gene's promoter in one parent so it won't be expressed. When this person produces gametes, in the germline these old imprints are erased, leaving a blank state. Then, depending on the sex of the individual, new imprints are made. So in this case, the gene can be expressed in chromosomes inherited from the mother, but not in chromosomes inherited from the father. Now let's say this gene has a mutation in it right here. The mother will not be affected, since this copy is imprinted anyway, and she has another copy which is expressed. However, if her offspring ends up with that copy, then they're in trouble, since the only other copy they get is from the imprinted version from the father. This is the case in Angelman syndrome, in which the maternal allele is deleted and the father's allele is imprinted. Patients with Angelman's will have intellectual disability, seizures, ataxia, and inappropriate laughter, and the combination of these has led to its nickname of the happy puppet. Now, Prader-Willi syndrome is similar, but is due to a deletion or mutation of a normally active paternal allele and an imprinted maternal allele. So it's basically the exact opposite as Angelman syndrome. Patients with Prader-Willi will have intellectual disability, hyperphagia, obesity, hypogonadism, and hypotonia. The genes that cause both of these are in chromosome 15. These syndromes can also be caused by uniparental disomy because if a gene is imprinted by one parent and the offspring receives both alleles from that parent, then they won't have a copy of the gene that they can express.